Okay, in this next part, ladies and gents, we're going to go over how to write a chemical equation based on it being described to you in words. This is a very good skill to have because they could ask you to do it on the AP exam. So let's go ahead and take a look right here. It says, write an equation for the reaction of aqueous sodium fluoride with aqueous magnesium chloride, which produces aqueous sodium chloride and solid magnesium fluoride. So now when we're going to write these equations, we need to make sure that we are writing the correct formula for each substance, that we are including the correct state in parentheses subscripted for each substance, and that we are also balancing the chemical equation as well. Okay, so reading this equation, or this question one more time, it says write an equation for the reaction of. Now, as soon as I see that phrase for the reaction of, I'm thinking, okay, what are my reactants? And it's saying aqueous sodium fluoride and aqueous magnesium chloride. Right? And then that's followed by which produces. As soon as I see that word which produces, I'm thinking, okay, whatever's coming after that's going to be the products. And for the products, it's going to be aqueous sodium chloride and solid magnesium fluoride. So let's go ahead and begin by writing this equation. We'll start with the arrow, which separates our reactants from our products. And the first reactant that it listed was sodium fluoride. I'm gonna need some more room. And it said it was aqueous. The second one that it listed was magnesium chloride. Said it was aqueous. And that's going to form sodium chloride. And I'm going to write it like this because I am going to run out of room, which is aqueous plus magnesium fluoride. Now, you might be wondering, well, this isn't a chemical formula, and for any teachers or anybody else watching this video, you can say, well, this isn't normal. You usually don't write the names in there like that. You write the formulas. I'm just writing it out this way so that you can see where the different substances are going, and now we need to convert these to formulas, okay? Now, you should already know how to write a chemical formula. So for sodium fluoride, you should automatically know that sodium, Na, has a 1+ charge. Fluorine has a 1- charge, so that's going to come together to make NaF, aqueous. And then the second reactant was magnesium, which is Mg, and that has a 2+ charge, followed by chlorine, which has a 1- charge. So that means this formula is going to be MgCl2, and it is aqueous. Excuse me. Again, you should know that already. Then we have our yield arrow, and then sodium chloride. Sodium is Na+, chloride is Cl-, okay, which means it's going to be NaCl, aqueous. And then for magnesium fluoride, you would have Mg2+, fluoride is F-, so this means this is going to need to be MgF2. Okay. And now we need to go through and balance the chemical equation. Okay. You should by now be getting good enough with balancing chemical equations that you could pretty much do them without the T-chart. And that's the way I'm going to do it with this one. I can see I have 1 sodium here and then 1 sodium here, so the sodiums are already balanced. I have 1 fluorine here, but 2 fluorines over here. I'm going to need to take care of that by putting a 2 out in front here. Okay. So now my fluorines are balanced. Yes, that throws off the sodiums, but we'll get to that later. Okay. The next one was magnesium. I have one magnesium here, and then one magnesium here, so those are good. The chlorines are not balanced. I have two chlorines here and one chlorine here, so I'm going to need to toss a 2 out in front right there. Okay. Alright, now when you're doing it this way and not the T-chart, you need to go back through and make sure that everything is balanced. Okay. I've got 2 sodiums, 2 sodiums. Oh hey, the sodiums took care of themselves. That's pretty good. I have now 2 fluorines and then 2 fluorines, so those are good. Magnesiums, I have 1 magnesium and 1 magnesium. Remember, this 2 right here does not apply that at magnesium, it only applies to that fluorine. So those are taken care of. And then I have 2 chlorines, and then 2 times that 1 chlorine, there's 2 chlorines. So this is balanced. Okay, let's do another example. 2 aqueous chemicals, lithium phosphate and sodium bromide, react to form aqueous lithium bromide and aqueous sodium phosphate. Write a balanced chemical equation. Okay. So it says 2 chemicals, lithium phosphate and sodium bromide react to form. That tells me that lithium phosphate and sodium bromide are my reactants. So let's do lithium phosphate. Said it was aqueous, is reacting with sodium bromide. Said this one was also aqueous, and it's going to form lithium bromide. So it was aqueous, and then finally sodium phosphate. So it was also aqueous. Okay. Alright, now to go through and then actually put in the chemical formulas. Now you're seeing things like phosphate in here. That's a polyatomic ion. So you are going to need to pull out your common polyatomic ion chart if you do not have those charges memorized. That's going to be on page 5 of your reference pocket. Alright, lithium has a 1+ charge. You should easily be able to get that by looking at the periodic table. And then the phosphate ion, PO3, has a -3 charge. I'm sorry, it should be PO4. Alright, that means this chemical formula is going to be Li3PO4 when you do the switcheroo like that. Aqueous. Reacting with sodium bromide. Sodium has a 1+ charge. Bromine or bromide has a -1 charge. You should be able to get that from the periodic table. That's NaBr aqueous. Alrighty, and I know that lithium bromide and sodium phosphate are reactants because it says reacts to form aqueous lithium bromide and aqueous sodium phosphate. So we are going to say lithium has a 1+ charge, bromine has a 1- charge. That means this is LiBr because they both have the same charge, or they both have same magnitude, just different signs. And then this is aqueous. Said that already. And sodium phosphate. Sodium has a 1+ charge. Phosphate has a -3 charge. So you need 3 phosphates to, or you're going to need 3 sodiums to balance out the 1 phosphate. So Na3PO4 aqueous. Okay, now let's go through and make sure everything is balanced. Okay. Start with the lithiums. I have 3 lithiums here and 1 lithium here. No, oopsies. We're going to need to put a 3 over here to balance out those lithiums. Yes, it changes the bromines, but we'll get to that later. Okay, this PO4, that is a polyatomic ion. We're going to consider that one whole group. I'm not going to look at the P separate or the O separate. It's PO4, one whole group. I have one whole PO4 here, and then one whole PO4 over here. They are balanced. They are good. Have the same amounts of PO4. Okay, sodiums. I have 1 here and 3 here. Oopsies, those are not balanced. Means I'm going to need to put a 3 out in front here to balance that out. Okay, let's check our bromines next. I've got 3 bromines and 3 bromines, so those check out. Alright, let's go back through one more time to make sure everything is balanced. 3 lithiums, 3 lithiums. 1 whole phosphate group, 1 whole phosphate group. 3 sodiums, 3 sodiums. 3 bromines, or bromines, and 3 bromines. Alright, that's balanced. What I'm going to have you guys do now is on the rest of the Nearpod activities, I'm going to have you work through the actual writing out of the chemical equation as well as balancing.